Here we have to show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. First of all, we will write what are given for us. Consider a quadrilateral ABCD. So we could write AC is equal to BD, which is given because the diagonals are equal. Also, AC and BD bisect each other. That is, OA equal to OC and OB is equal to OD. And they are bisected at right angles. That means each angle formed around O is 90 degree. Before starting proof, I would rather like to point out that what if the diagonals of a quadrilateral bisect each other? Then that quadrilateral would be a parallelogram. So here we could say that ABCD is a parallelogram. So we are going to start our proof by considering ABCD as a parallelogram. Now focus on what we need to prove. We have to prove that ABCD is a square. For that, it is enough to prove that all sides are equal and its angle, one of its angle is 90 degree. The first thing I am going to prove that all sides are equal. I am going to prove this with the help of the congruency of triangles. So select two triangles in which one of its sides to be the sides of ABCD. Here I am going to select the triangle AOB and AOD. In both the triangles, AB and AD becomes the sides of the ABCD. And in these two triangles, it's clear that AO is equal to AO because it is common for both of them. Now OB is equal to OD because it is given that the diagonals bisect each other. Next, AOB is equal to angle AOD. Both of them is 90 degree because it's again given us that the diagonals bisect each other at right angle. So angle formed around O are 90 degree. Therefore, by SAS congruency rule, we can conclude that triangle AOB is congruent to AOD. Since these two triangles are congruent, their corresponding sides, that means AB and AD, are equal. Similarly, that means by following the same steps, we can prove that AB is equal to BC by proving the congruency of triangle AOB and triangle BOC, and BC is equal to CD by proving the congruency of BOC and COD, and CD is equal to DA by proving the congruency of COD and AOD. So no need to write all the proof. It is enough to write as similarly AB is equal to BC, BC is equal to CD, and CD is equal to DA. And from combining all this together, we can say that all the sides are equal. So our first part was over. Now we will move into our second part. That is, we have to prove that one of its angle is 90 degree. For that, first I am going to consider the property of parallelogram. That is, the adjacent angles of a parallelogram is supplementary. So here, if I took angle A and angle B as two adjacent angles of a parallelogram, then I can write here as angle A plus angle B is equal to 180 degree and take it as equation number 6. Now, if we were able to show that angle A is equal to angle B, it is easy for us to prove that both of them is 90 degree. For proving that, I am going to consider two triangles in which angle A and angle B becomes one of its corresponding angles. So consider triangle DAB and triangle CBA. In both the triangles, angle A and angle B become the corresponding angles. Now we will try to prove the congruency of these two triangles. In these two triangles, AB is equal to BA, that means which is common for both of the triangles. Now DB is equal to CA, which is given, that is the diagonals of this quadrilateral are equal. Now AD is equal to BC, which we have already proved. So by SSS congruency rule, we can say that triangle DAB is congruent to CBA. Therefore, the corresponding angles, that is angle A and angle B, are equal. Now we can apply this result in equation number 6. And by applying this result in equation number 6, we can rewrite angle A plus angle B is equal to 180 as angle A plus angle A is equal to 180 degree. That means 2 times angle A is equal to 180 degree. Therefore, angle A is equal to 90 degree. Hence we proved two parts of it, that is all the sides are equal and one of its angle is 90 degree. So we reached to the conclusion that ABCD is a square.